Hi, and welcome in this tutorial video about the UniREST solution. So, let's start. What UniREST is. UniREST, formerly UnityREST, is an all-in-one solution to easily connect your Unity game with your online database. But what does it mean, connect? It means that, once you have installed and set up the UniREST solution, your game can send data to your database, to save them, and read data from your database. So, it's a perfect solution if you want to develop an online game, where your game data is managed into an online database. You don't want to spend time developing a server-side application. You don't want to invest a lot of resources, and also money, in a complex server solution. Now, how does UniREST solution work? UniREST consists of two applications, the UniREST server application, and the UniREST client asset. The UniREST server is a very easy-to-use web application you have to install in your online solution. That can be a classic web hosting, a simple virtual server, or a dedicated server as well. The UniREST client is a Unity asset you have to install in your game, to have the methods and tools to create your online game. Once both applications are installed and properly configured, your game and your database can communicate and exchange data. Before talking about the two applications, I'd like to spend some word about a hot topic, security. In a system like this, where you have a game and a server that communicate, an intruder can try to steal your data in 3 locations: entering in your server, reading your game source code, or watching the data transmission. From the UniREST server solution point of view, server and source code protection should be managed by the owner with the appropriate tools. Instead, the UniREST solution uses some built-in techniques to offer a good level of protection during communications. How does this protection work? Firstly, the data is encrypted using secret keys during all the communications. This means that, even if an intruder reads these communications, without the keys, he can't read their content. Secondly, the communication uses the tokens system to authorize every operation your game performs on your database. Basically, when your game and your database start to communicate with each other, the UniREST server application constantly provides some tokens to the UniREST client. Successively, when your game needs to do something in your database, the UniREST client will perform the new operations, sending back the tokens. The UniREST server application will check the validity of these tokens. If everything is okay, the communication will continue. If something goes wrong, your game request is refused. What happens if an intruder intercepts a request and tries to use it again? The intruder request is refused. This because the previous request has been already processed, and the tokens have changed. Practically, the intruder has stolen an encrypted request, with invalid tokens. Now, let's see what the UniREST server application is, and how it works. The UniREST server is a web application that allows you to set up the server-side environment through a graphical interface. So, no coding is required. Moreover, it's an application built on top of the WordPress framework. Why WordPress? WordPress is a well-known content management system, used by a lot of users and companies to create from simple websites to complex web portals. It comes with a robust, secure and efficient framework that allows web developers to create new functionalities. It has everything the UniREST server application needs for working: database management, REST API technologies, built-in security systems, an administration area, and so on. These are the advantages of using WordPress. It's a well-known and documented environment. Its framework is robust, secure, efficient and lightweight. It already has all the technologies used by the UniREST server applications. It doesn't require complex and expensive server features, and it's supported by many providers. Once installed, you can install the UniREST server application with just one click. Now, I'm going to show you how to install the UniREST server application. For this procedure, I decided to use one of the various free hosting services with WordPress support. Obviously, all this is for demonstration purposes only, and the use of this type of service is not intended as a recommended solution for developing online games. Anyway, once you have correctly installed WordPress, you are ready to install the UniREST server application. The application is simply a classic WordPress plugin, so you have to install it with the same procedure with which the plugins are installed. Click the Plugins menu, click the Add New button and then the Upload plugin button. Now, select the zip file containing the UniREST server application and click the Install Now button. The application should be installed quickly. Finally, click the Activate plugin button and the UniREST server application is ready to be used. To start the application, just click the UniREST server menu item and then, in the Welcome page, click the Open button. The first time you run the application, it has to perform a system initialization. Click the Start button. If everything is okay, in a couple of seconds, a message will inform you that the configuration is completed. Now, you can start creating database tables and APIs. In this tutorial, I'm going to create the tables to use with some APIs, to set up a Unity example project. To make all simpler, I won't talk about technical aspects, such as database management or REST technologies. For these details, I invite you to read the online manual. The Database Manager allows you to create the tables you need for storing your game data. This tool aims to offer a very fast and practical way to create database tables. As you can see, the UniREST server application has already created a table called Users. This is a system table, so you can read it only. To create a new table, simply click Add New button. Then, type a name for the table, and click Add New column for adding the columns you need. In this example, I'm creating a table to store the player data, as his name and characteristics. Moreover, I need a column to store the user ID, to link the player record to the ID of the registered user. I also include a weapon ID column, to assign a weapon to the player. The weapon features are stored in another table. Once all the columns and their data type have been set up, click the Create Table button, to add this table to your database. Now, you can perform some basic operation on this table. For example, you can modify its structure, delete it, and manually add some record. For this example, I create a second table, where to store the game weapons and their characteristics. In this case, I manually add some record, to have some weapon to use. So, what tables I have now, and how they are connected. I have 3 tables: Users, the system table, that contains the user's account. Player, a custom table, that contains information about the user's player, and that's connected to the user table by the user ID. Weapons, another custom table, that contains the list of my game weapons. Each player is connected to this table by the weapon ID. So, for example, I know that the user first play 82, has a character named Conan, who has got a sword. Now that I have the tables to store my Unity game data, I have to create the APIs for reading data from these tables, writing data into these tables, and performing the other operations I need. The API Manager allows you to create the APIs to put your Unity game, and your database tables, into communication. Basically, an API allows you to perform, from your game, the 4 possible table operations: reading records, writing new records, updating existing records, and deleting unnecessary records. To create a new API, click the Add New button. This will start the creation of a new group of APIs. In the UniREST server application, APIs are organized in groups. A group should represent a topic, and contain the APIs related to that topic. In this example, I'm going to create the APIs to manage a player's data, so I call this group Player. To add an API to this group, just click the Add New API button. This will show a rectangular area where to define this API features. So, I call this API data, and I type a short description in this text box. This is optional, but it will help me to better organize my APIs. Now, I must select the database table this API will work with. I select the player table I had created in the database manager. It's time to define what this API can do. Here, I have the 4 operations: read, write, update, and delete, plus a custom SQL option that allows me to define complex behaviors. But in this tutorial, I'm going to show just the main features. The first operation I want to activate is read. From now, the player data API can read data from the player table. All the operations panels show some specific option on the left side, and all the table columns on the right. For each column, I have a specific list of options. In this case, the read options I have are read. This means that the API will release the value of this column to my Unity game. None. This means that this column will be ignored. Key. This means that the value of this column will be used as an ID to locate a specific record, or a specific group of records, in the player table. In this example, in the player table, I have one record for each user. So, I have to use the user ID value to localize the specific user record. I let the read option in the other columns, because I want to read all their values. Because I expect my Unity game will receive one record only, I flag the one record only option. In this way, I'm sure I will have one record only. It's optional, but without this option flagged, my game will receive an array. The order by options can be used if my API reads more records, and will release an array of found records. Here, I can choose the column to use for ordering, and the ordering direction. The second operation I want to activate is write. From now, the player data API can write new records into the player table. Here, I can just choose if a column must be written or ignored. Keep in mind that all the columns flagged with the write option require a value. So, when your game will call this API for writing, it must provide all these values. The third operation I want to activate is update. From now, this API can update the values of existing records. The options I have for the columns are update. This means that the API can change the value of this column. None and key, which work as described before. Similarly as the read operation, also, in this case, I have to localize the record to update, and I will use the user ID. So, when my game will have to update this record, it will provide the user ID to locate this record and all the values of the columns flagged with update option. The last operation I want to activate is delete. From now, this API can delete existing records. The delete operation just requires to know which records to remove, and, for this reason, only the none and key options are available. Also, in this case, I want to delete the player record, so I'll select the user ID as key. Now, I have the player data API fully configured. But, let's go back to the update operation. Previously, I explained that the update operation will require all the values of the columns flagged with update. What if I wanted the freedom of updating just one, or two, of these values? In this case, I can activate the dynamic update option. From now on, I'm no longer forced to update all values, but I can choose what to update. For example, now I can only upgrade gold, or health, or both. Another useful option I can activate is can write. How does it work? Can write option is specifically designed when you are going to work with one record only. If your API has the write and the update operations, it's expected that, firstly, you write the new record, and then, you update that record, using an ID to localize it. In this case, you can avoid the use of write, and have the update operation only, with the can write option enabled. What will the API do? It will search the given ID in the table. If it's not found, the API will write a new record, with the given data. If it's found, the API will update that record. For this reason, I can disable the write operation. Now, I create a new API. I will use this API to read the details of the weapon owned by the player. So, I name it weapon, I type a short description, and I select the weapons table. The only thing I want to do with this API is to have access to weapon data, so I just activate the read operation. The weapons table just contains a list of game weapons. The weapon owned by the player is indicated by the weapon ID, which is the ID of the record into the weapons table. So, in this case, I have to check the ID as key option. Also, here I expect to get one weapon only, so I flag the one record only option. My APIs group is completed, and I click the Save button. Now I can work with these APIs from my Unity game. Coming back to the API Manager home page, I will find the APIs index with the list of my APIs, and their specifications. The UniREST client is a Unity asset you have to install in your Unity game project. Once installed, your project will have a Tiger Forge folder containing the UniREST client asset. The asset consists of two scripts. The UniREST client script is a class containing the everything you need to communicate with your database. The UniREST client config is an empty file you have to fill with the configuration script provided by your UniREST server application. So, the first thing you must do is to configure the UniREST client environment. Enter your UniREST server application and, in the home page, click the Create Client Config button. The system will generate for you the C script you have to copy and paste in the Unity asset. Remember that, every time you update something in your database and your APIs, you must regenerate this script and update your Unity configuration file. Now, let's copy the script and paste it into the UniREST client config file, replacing the current content. The UniREST client is ready to be used. Before to explain how to use this asset, let's take a look at what this script is, and how it works. As explained at the beginning of this video, the communications between your game and your server application are encrypted. So, the first informations this script provides to the UniREST client are the secret keys to use in the encryption system, and the HTTP URL of the REST server. You must keep those information secret. The keys are automatically generated once, when you install the server application for the first time, and they must not change during the whole life of your game. They must be the same, in both server and client side. If they change in one side, the communication will fail. Moreover, always check that the server URL is correct and fully working. The code above contains information about your APIs and database tables structure. Basically, all your APIs addresses are stored inside a class named API in specific properties with the same name of your APIs. When you need to call an API, you must use the API class. This approach will help you to avoid the typing of wrong addresses, or the need to remember them all. The database tables are replicated as serializable classes inside the DB class. Each class has the same table name, and the properties replicate the table column's name and data type. This approach will help you to exchange data with your server application, without running into errors due to wrong names or data formats. Now, we are ready to use the UniREST solution. For this tutorial, I have just created a canvas, with some text boxes and buttons. The scope of this demo is to show how information are exchanged between a Unity game project and the UniREST server application. I already have created a simple mono behavior script attached to my main camera component. It simply contains the public properties that create links to this canvas elements. The first thing to do is to set up some kind of system to register new users and allow the users to log in. The UniREST solution just requires a unique username and a password. It is up to you to decide how to ask the user for this information. In this demo, I'm going to use a simple form where to type username and password, but you are free to do what you want. For example, you could automatically generate this data when the user starts your game for the first time. Anyway, in my mono behavior script, I import the Tiger Forge namespace. In this way, the UniREST client class will be directly accessible. Now, I add the default Unity start function. A useful thing to do, when I start creating a new project, is to enable the UniREST client debug mode. Setting it to true, all the communications will be shown on the Unity console, with colors and formatting that make everything clearer. Now, I have to make the register and login buttons clickable. So, I define the required functions, and then, I enable the click event listeners on those buttons, in order to call these functions. One of the scopes of the UniREST solution is to make things as simple as possible. So, all the UniREST client methods ask for just the minimum necessary to work, and release only the requested data or very brief information. To register a new user, just call the registration method. As you can see from the IntelliSense, it just requires username and password, and it just releases true if everything is okay, or false if something goes wrong. Therefore, I pass to this method the username and password from their text boxes, and I use the result variable to get the registration result. In the following piece of code, I use the result variable to know if the registration has gone okay or wrong. I use the txt result label to show, on the canvas, the operation result. If something goes wrong, the registration method just releases false. If I need to know, in details, what has happened, I can simply use the server error property, which contains information about errors that occurred in the UniREST server application. Let's try this code. I start the game, I type a username and a password, and then I click the register button. The registration was successful, and here, in the console, I can see what happened. Here, I can see also a very important thing. This string of random letters is the message generated by this game, and sent to my server. This shows that my account was not sent to the server in clear text, but was sent decrypted. Let's come back to the UniREST server application, and look at the users table. As you can see, the Tiger user has been added, and the password is coded. And now, what if I try to register again this username? I simply get an error. The server error property contains the string invalid. And what if I type an invalid username and password? Same result. It's time to code the login functionality. The method to use is login, and the code is practically identical to the registration method. So, I can simply copy, paste, and modify this code. Let's try it. I start the game, I type my account username and password, and then I click the login button. The login was successful and, again, here in the console, I can see the process debugging. As you can see, my account data has been sent encrypted to the server. But, in this case, the server replied to my game, and also this reply is encrypted. Now that I'm logged in, and my account has been authorized to operate with the server application, I can use my APIs so as to perform operations with my database tables. And what if I try to log in with a wrong username or password? I always get the no_account error message. What I want to do here is to show my player data when I click the read button. It is just my example. Instead, you may want to read this data immediately after the user login. It's just a choice. However, looking at my player table, I don't have a record to read. So, I have to write one first. In a database table, the writing process consists of two separated actions, writing and updating. Keep in mind that writing means adding new records to a table. If you want to write, in order to change existing data, you must perform updating. Before to code the writing feature, I have to look at my APIs. Indeed, my player data API doesn't have the write operation. Instead, it has the update operation with writing capability. This is important because read, write, update and delete operations have their specific methods. Let's back to Unity. In my demo project, I'm going to ignore the write button, and instead, I will use the update button, both for writing and updating, because my API works in this way. So, firstly, in my mono behavior script, I code my update button so as to make it clickable. Then, I use the update method. Basically, all the operation methods require two parameters. The first parameter is the API I want to use. The APIs are available through the UniREST API class. The API I need is player data. The second parameter is the data I need to work with. Because I'm working with database tables, my data structure must reflect the same table structure I'm going to work with. For this reason, my data must be always instantiated with classes from the UniREST DB class. My player data API works with player table, so I must use the db.player class. Now, what data do I must send to the UniREST server application? In the update operation, the columns set as key are mandatory. This means that I must send the user ID. The other columns, name, gold, health and weapon ID, are not mandatory, because of the dynamic update feature enabled here. But, in my example, I'm going to always send them all. In the declaration of the second parameter, that is an instance of the database table, player, I have to pass all the values I want to write, and update. The user ID is a system value, which is stored in the UniREST client class, when the user logins. It is available in the user ID property, and it must be used every time you need to do something related to the user account ID. For the other values, I take them from their text boxes. Because the values from the text boxes are strings, I have to cast them into the proper data types. As you can see, the db.player class replicates the player table structure. Now, I'm going to use the result variable to know if the writing process is working as expected. In case of failure, I can get detailed information through the db_error property. Let's try this code. I start the game. The first thing I must do is to log in with my account, but I'm going to not do it. What if I try to do something without being logged in? I simply get an authorization failure. So, I log in into the system, and now I click Update. The write is done, and in the player table, a new record has been created. And now, what if I click the Update button again? Because a record with the user ID already exists, this time the update method will perform an update. I haven't changed anything, so there is no evidence of the update. But, if I change the value of gold and health, and I click Update, I can see that the two values have been updated in the player's record. Now that I have a record, I can develop the reading operation. My player data API has two elements I have to consider before writing code. Firstly, it requires the user ID, because the scope of the read operation is to release my player data. Secondly, the one record only option is checked, so I will receive a single group of data. I have to consider this, because the read operation releases an array of records without this option flagged. Therefore, I add the code for making the read button clickable. For reading, I have two methods, read and read1. The first for reading an array of records, the second for reading one record only. I chose this last method. The method will release an object with the structure of the player table, so I must use the db.player class to get the record data properly. As always, the first parameter must be the API to use, and the second parameter, an instance of the db.player class. In this case, I'm using this instance to send the user ID my API needs to localize my player record. If everything goes as expected, I will get a db.player object with the record data. If something goes wrong, I will get a null object. So, if I get a null object, I show an error message. Else, if all is right, I can show the received data in the canvas text boxes. The only thing I have to remember is to call the toString method for converting the numeric values into strings. Let's try this code. I start the game, and I log in with my account. Now I click the read button. The record data are correctly shown. What I want to do now is to show my player's weapon name and attack value. For this scope, I have the dedicated API, player, weapon, which requires the record ID that I have in the player table under the weapon ID column, and that will release one record. In my mono behavior script, I'm going to develop this part into the read button click event, because I need the weapon ID. The code is identical to this one, so I copy the script, and then, I will modify it, as I need. Firstly, I change this variable in result weapon. The record I'm going to get belongs to the weapon table, so, secondly, I must change the db class. Then, I have to call the write API, and, finally, set the ID equal to the weapon ID from the previous reading result. Now, I update the if statement with this new result. Let's try this code. As you can see, also the weapon details have been correctly read and shown. Just to check if everything is working right, I change the weapon ID, then I update, and, finally, I click read. As expected, here I have another weapon. The last operation I want to develop is delete. My player data API just requires the user ID. As for the other examples, I'm going to implement the code for making the delete button clickable. The method I need to use is delete, and it has to be configured in the same way of the other methods. So, here I specify the API to use, and here I initialize db.player, setting the user ID property with my account ID as requested by this API. For checking the result, I just reuse this piece of code, and I modify it for my needs. Let's try this code. As for the other times, I log in and click the delete button. The cancellation took place. Now, I check my player table in the database, and, as you can see, the record has been deleted. That's all. In this tutorial video, I've shown you the main features of the UniREST solution, and quickly how to use it. For more information, I invite you to consult the online manual, or contact me.